Hello children, I am Veeralakshmi from Guntur Arandalpeta branch. So we are discussing assignment related to the topic classification of elements. In that question number 1, define electron affinity. Electron affinity, or this is also called electron gain enthalpy, or E is represented with EA. Is represented with EA. The maximum amount of energy released, the maximum amount of energy, maximum amount of energy released when an electron is added to valence shell of isolated neutral gaseous atom. Isolated neutral gaseous atom. So this is called electron affinity. It is represented with EA. Next, question number 2. Define electronegativity. So T is represented with symbol in shortcut En. So the tendency of bonded atom to attract the bond pair of electrons. Towards itself is called electronegativity. So we have here, if you see, isolated, in case of electron affinity, isolated means the atom should be unique, whereas neutral means it should have equal number of electrons, protons. Whereas gaseous state, in gaseous state only there may be a chance to be existed in native state, isolated position. So we have to convert, whether it is a solid element, we have to convert into gaseous state by heating, by subliming, whatever the process we apply. We have to convert the atom into gaseous state and should be in neutral. It should be isolated, whereas the distance between the gaseous molecules is very high. In that case, when an electron is added to the valency shell, after adding the electron, the energy released is considered as, the amount of energy released is considered as electron affinity. Whereas in case of electronegativity, if you have taken example HCl, the bonded electrons, it is a non-polar covalent bond formed by equal contribution and sharing of electrons. The shared pair of electrons is completely attracted towards chlorine atom. Because it is having high electronegative nature. So because of that attraction, they acquires the partial charge development, partial positive charge, partial negative charge. So the tendency of an atom to attract the bonded electrons towards itself is called its electronegativity. Next. So question 3. So electron gain enthalpy of alkaline earth metals, that is second A group elements, and inert gases, those are 8th A group elements. So for these two substances, the electron gain enthalpy is positive. So already what we discussed about electron affinity definition, it is release of energy. Release of energy means exothermic. The energy should be negative. The representation of release of energy we represented with a negative sign. Whereas in case of alkaline earth metals, inert gases, the electron affinity or electron gain enthalpy is positive. Why? What is the reason for that? Means if you observe the alkaline earth metals, general valency shell electronic configuration is NS2. Whereas inert gases general valency shell electronic configuration is NS2 NP6 except NS2 NP6 except helium. So because of their fully filled valency shell, there is no space for upcoming electron to accommodate the newly coming electron. So that's why if you want to try to add one more electron, if you try to add one more electron, it takes, if you try to add one more electron to their valency shell, this is what valence shell electronic configuration. Valence shell electronic configuration. No? So if you try to add one more electron, it needs energy due to that released amount of energy is less when compared to the absorbed. It should absorb some amount of energy to accommodate that electron. It absorbs and releases energy. It releases energy and also absorb the energy. Absorb the energy. On comparing the two energies, so the absorbed energy is more than the released amount of energy. The absorbed energy is more than the released amount of energy. That's why are considered as endothermic in nature. Their electron gain enthalpy process is endothermic in nature. Next. Question number 4. How the following properties, periodic properties changes in groups and periods, especially electron affinity. Electron affinity in periods from left to right, the electron affinity is increases due to decrease of size and increase of nuclear attraction. Due to decrease of size and increase of nuclear attraction. Increase of nuclear attraction. Whereas in groups from top to bottom. In groups from top to bottom, the electron gain enthalpy, electron affinity is decreases due to increase of size, and a decrease of nuclear attraction. There is no nuclear attraction, less nuclear attraction, then electron gain enthalpy, there may be less chance to accommodate electron, also decreases. So whereas electron negativity in periods as in the same way, the variation is same compared with electron affinity, even though the explanation is different. So in periods from left to right, it is increases, where due to the increase of nuclear attraction, in periods electron negativity is increases, whereas in groups the electron negativity is decreases due to the decrease of nuclear attraction. Electron negativity is nothing but attraction, no? So that's why in periods from left to right, electron negativity increases. In groups from top to bottom, electron negativity decreases. Next question number 5. So we have given one of the short period elements. The elements belongs to short period like lithium, beryllium, boron, carbon, nitrogen, fluorine. So among these periods, with the help of this period elements, we have to answer the following questions. So first question, these elements belongs to which period? They are asking that which period, the number of period belongs to these elements. So they belongs to second period. How can we say that they belongs to second period? With the help of their valency shell electronic configuration. So atomic number of lithium is 3, beryllium 4, boron 5, carbon 6, nitrogen 7, Whereas fluorine 9, we are arranging the elements according to modern periodic table in the increasing order of atomic weights, atomic number. So based on that, second question is which element is missing among in this period. So the eighth element, that is oxygen, is missing. Oxygen is missing in this period. Missing element. Next, third question is which element belongs to halogen family? Which element belongs to halogen family? Seventh, A group element, that is fluorine. Fluorine belongs to halogen family. Belongs to halogen family. So whose electronegativity value on Pauling scale is 4.0. Is 4.0. So by observing the configuration 1s2, 2s1, for this 1s2, 2s2, for this 1s2, 2s2, 2p1, for this 2s2, 2p2, 2s2, 2p2, for this 2s2, 2p3, for this 2s2, 2p4, for fluorine 2s2, 2p5. So last shell number is 2. That shell number indicates the period number. So next, based on this data, fourth question also. Fourth question, what they asked means from left to right, explain the variation of metallic character. So from left to right, the metallic character decreases. From left to right, metallic character decreases due to the decrease of size, and increase of attraction. So are not allowed to, because of small size they won't lose their electrons. Metallic character is nothing but tendency to lose electrons. So as we move from left to right, metallic character decreases. That's all for this assignment. Thank you.